Video 266, more compositions and their domains. Find each of the following: f compose g of x and g compose f of x. So here we are. By definition of f compose g, that means we're going to take the stuff that's in g of x. We're actually literally going to take the entire function and use it as an input value for f of x. That's why we're going to take 6 over x and plug that into wherever you see the variable for the function f. This gives us this first step here of 2 times 6 over x over 6 over x minus 9. Then, in the next step, we're going to go ahead and multiply both the top and bottom by x, because then that would allow us to get rid of the complex fraction. We have a fraction within a fraction. That's basically the simplest definition of a complex fraction. It's not simplified, therefore we would then multiply by 1, which is x over x here. Then we get here. This is f compose g. Okay? That's f compose g. Now the domain, which is on the next page, think about this. X cannot be, well, x cannot be 2/3, right? If you the denominator cannot be 0. So if you move the 9x over, x cannot be 2/3. Now, some people might think that that's all there is to it. However, there's more to that story. Let's see here. That's this one right here. There's more to the story than just 2/3. X cannot be 2/3, but x also cannot be 0. Not because of this. X can certainly be 0 here within this fraction. But you see, in order to get to this step, everything prior to that needs to have been something that's allowable, okay? Cannot be 2/3. X cannot be 2/3 because that would cause us to be undefined. And then everything back here, x can't be 0, right? X can't be 0 here. So therefore, we cannot have 0 or 2/3. So here's our interval notation for that. Next one is, well, it's g compose f. Where's that one? That one is right here. G compose f. We're going to take the f of x function and plug it into g. So we're going to take 2x over x minus 9, and we're going to put that into as an input value for the g function. So we take the 2x over x minus 9 and put it in the denominator 6 over x. This is a fraction within a fraction. Multiply by the reciprocal, multiply across, you're all set. Okay, you end up with 6x minus 54 over 2x. Of course, you can divide each of these 3 by 2, so we end up with 3x minus 27 over x. And of course, x cannot be 0 here, but again, you always check your steps prior, and x was not going to be allowed to be 9 here. So therefore, we will have the following. All right, so that is more function compositions and their domains, and we'll see you around.